Today we're going to be talking about making equivalent fractions, which is basically directly related to what we were actually doing yesterday when we were finding a common denominator, okay? So equivalent, all right, comes from the word equal. So when you're making equivalent fractions, you're making fractions that are equal to each other. And again, this is what we did yesterday when we did common denominators. So let's say yesterday when we did common denominators and I had 1/3 and 2/5, right? And yesterday we had to change them so that they had the same denominator so that we can add them. Because remember, we can only add fractions that have the same denominators. So we listed the multiples: 3, 6, 9, 12, 15, 18, 5, 10, 15, 20. Oh, wait. We listed the multiples of 3 and 5 and found out that they shared 15. So 15 was our lowest common multiple, and we used that to make our lowest common denominator, okay? So what we did is we changed 1/3 and 2/5 to 15ths, all right? And one of the things that we talked about when I did that with you is I drew the equal sign next to it, and I drew 15 for the new denominator for each one. And what we talked about yesterday is if you change the denominator, you need to change the numerator by the same amount. What you're doing is you're making equivalent fractions, which is why there's an equal sign here. There are two fractions that are equal to each other and will make the same amount of something when you put them together. Okay, so thirds and 15ths are not the same size, but you can use 15ths to make something that's the same size as a third. So equivalent fractions are made by either multiplying or dividing, okay? In our case, when we're making a least common denominator by using the least common multiple, we're multiplying. We ask ourselves, well, how did I change 3 to 15? What did I multiply 3 by to get 15? Oh, I have to multiply 3 by 5 to get 15. So, the rule of equivalent fractions: whatever you do to the bottom, you must do to the top. And whatever you do to the top, you must do to the bottom. So, you need to, if you multiply the bottom by 5, you need to also multiply the top by 5. So 1/3 becomes 5/15. So what that means, when we're adding, why we can do this is because 5/15 will make the same size piece as 1/3. Okay, so if you have a third, okay, and you were to cut each of those thirds into 5 pieces, you would end up with 15 pieces. Okay, and I'm not doing a great job doing this evenly, but I'm doing my best. So 1/3 would have been this big, okay? And inside 1/3, you have 1, 2, 3, 4, 5/15ths. So 1/3 and 5/15ths are going to make the same size. So that's the reason that we can change them like that in order to add. All right? But whatever we do to the bottom, we must do to the top. So over here, we would take our 5 times what equals 15? Well, 5 times 3 equals 15. If I multiply the bottom by 3, I must also multiply the top by 3, and I'm going to get 6/15ths. And then they can be added together, or they could be subtracted, so pay attention to your signs. We subtract fractions too, we just don't always add them. So you're going to get 11/15ths, okay? So this is an equivalent fraction for that, and this is an equivalent fraction for that. And you can make equivalent fractions by multiplying and dividing both the top and the bottom by the same number. So what that means is if I have a fraction like 3/5, okay, let's say a 3/5 by myself, as long as I multiply both the top and the bottom by the same number, so if I multiply both the top and the bottom by 2, I'm going to get 6/10. 6/10 is the same thing as 3/5. I can take 3/5 and I can multiply the top and the bottom by 4. And I would get 12/20, which is going to be the same as 3/5, which is also going to be the same as 6/10 because 6/10 is the same thing as 3/5. So I can make an equal fraction to any fraction just by multiplying the top or the bottom by the same number. I can also divide. So if I had 12 20ths, and this gets a little trickier because it has to be the same number and it has to divide evenly. So I couldn't divide them both by 3 because 20 divided by 3 doesn't happen evenly. But I could divide them both by 2, which means 12 divided by 2 is 6, and 20 divided by 2 is 10. So 6/10 is an equivalent fraction for 12 over 20. All right? And this is important, and you can do it with any number, but when you're adding or subtracting, you have to make sure you're doing it with a number, making a number that's the same for both fractions, which is why we have to list out the multiples. All right.